Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate the projections of a line which happens to be parallel to the profile plane. Now since this line happens to be parallel to the profile plane, so the true length projections of this line onto the profile plane will be obtained, and in the front view as well as in the top view we are going to obtain the apparent length projections of this particular line. So let us go through the statement of this problem. So points I and J, so these are the 2 points which are going to comprise line IJ. It is lying parallel to the profile plane. Now here we have the point I, which happens to be 40 millimeter above the horizontal plane, and it is lying on the vertical plane. Whereas the point J, it is 50 millimeter in front of the vertical plane and it is lying onto the horizontal plane. And the distance between their projections, that is the projections of the points I and J, as measured parallel to the XY reference line, it happens to be 0 millimeter. That is, we have got line IJ parallel to the profile plane in this particular case. So with this information, we are required to draw the front view projections, the top view projections, and the right hand side view projections of the line IJ on the common reference lines XY and X1Y1, and we will also be connecting the respective views with the object line, that is the front view I dash will be connected to J dash, the top view I will be connected with the point J projection, and finally, I double dash projection in the side view will be connected with J double dash projection in the side view corresponding to the line IJ. So let us first of all spatially locate this line IJ in the 3D projections over here. So here we have got the horizontal plane. So this is the vertical plane, and we have got one profile plane on the right and another profile plane we have obtained on the left hand side. So here we are required to draw the front view, top view, and the right hand side view projections of this line IJ. So since the right hand side projections of this line, they are to be obtained, so this projection, right hand side view projection of the line IJ will be obtained on the profile plane which is located on the left hand side of this particular 3D environment, right? So we are going to talk about this horizontal plane. This is going to contain the top view projections of the line IJ. This is the vertical plane which is going to contain the front view projections of the line IJ, and this is the left side profile plane which is going to contain the right hand side view projections corresponding to this line IJ over here. So let us plot the projections of the points I and J. So point I, it is located 40 millimeter above the horizontal plane and it is lying on the vertical plane. So please check, here we have got the location of the point I, which is located in the 3D projection environment. So point I, it is located, please check, 40 millimeter above the horizontal plane or the XY reference line, and it is contained by the vertical plane. So point I has been located onto the vertical plane. So this is point I. Similarly, there is another point, point J, which happens to lie 50 millimeter in front of the vertical plane and it is lying onto the horizontal plane. So this point J, it is lying 50 millimeter in front of the vertical plane. So this is our vertical plane. So we can check over here. This point J, it is lying 50 millimeter in front of the vertical plane, and this point J, it is contained by, or it lies on the horizontal plane. So this is the horizontal plane which contains the location of the point J, which is 50 millimeter in front of the vertical plane, and the distances between the projectors from point I and point J measured parallel to the XY reference line, it happens to be 0 millimeter. That is, I and J projections, they will be falling along the same vertical projector line perpendicular to the XY reference line. So this is my XY reference line. So measured perpendicular to the XY reference line onto the same vertical projector, the points I and J, they will be lying. So here we can see point I is lying 40 millimeter above the horizontal plane and into the vertical plane. Point J is lying 50 millimeter in front of the vertical plane and into the horizontal plane. So the distance between the projectors of point I and J measured parallel to the XY reference line, it is 0. So we can say that this I and J point, so both of these 2 points, they are lying parallel to the profile plane, right, at a same distance from the profile plane. So having obtained the coordinate locations of the points I and J onto the 3D coordinate system environment, now so we can join the points I and J over here. Now having joined the points I and J, now we can look at these 2 points from the front. So if we are going to look at both of these points from the front, point I will be located, it will be projected as I dash 40 millimeter above the horizontal plane into the vertical plane in the front view projection. Similarly, point J dash, it will be projected onto the XY reference line. So I dash has been obtained, J dash has been obtained as front view projections of this line. So we will be able to obtain I dash, J dash as the front view projections onto the vertical plane. And now since this line IJ, it happens to be inclined to the vertical plane, so we will be able to obtain apparent length projections of this line I dash, J dash in the front view projections. Similarly, if we are going to look at this line IJ from the top, point I will be projected onto the XY reference line over here at a 0 distance from the XY reference line, and point J will be projected onto the horizontal plane at a distance of 50 millimeter from the vertical plane, that is 50 mm below the XY reference line. So I point is obtained on the XY reference line, J point is obtained 50 mm below the XY reference line. So if we join I with J as the top view projections of this line IJ obtained onto the horizontal plane, so again, because of the inclination of this line IJ with respect to horizontal plane as well, we are going to obtain the apparent length projections IJ onto the horizontal plane as a plan. Now we have to obtain the projections of this line IJ onto the profile plane. So since now the observer is going to look at this line from the right hand side, so point I will be projected onto this profile plane which is located on the left hand side. So please check, this is the profile plane which is located on the left hand side. So the right hand projection, right hand side projections of the line, they will be obtained on the left hand side in the first quadrant, in the first angle projections over here. So point I, it has been projected as the observer is going to look at this point from the right hand side. So this will be projected on the profile plane located on the left hand side, and this point coordinate will be I double dash. Similarly, point J, when the observer is going to view from the right hand side, it will be projected on the left hand side profile plane as point J double dash. And now once we have obtained I double dash and J double dash points over here, and we join this I double dash with J double dash point, so we are going to obtain the true length projection of this line which has been obtained on the profile plane which is located on the left hand side. So this way we have completed the discussion of the spatial location of these 2 points I and J into the 3D environment with reference to the horizontal plane, vertical plane and the profile plane over here. Now let us proceed with the construction of the orthographic projections of this line IJ, which happens to be parallel to the profile plane. So here we have got the front view projections. Here we are going to draw the top view projections, and here we are going to draw the profile view, that is the right hand side view projections we are going to draw on the left hand side of the front view. So here the front view will be drawn on the vertical plane. Here the top view will be drawn onto the horizontal plane. So here we are going to draw the right hand side view projections onto the left hand side profile plane. So now with the given data, let us plot the points I and J in the side view projection. So why we are going to draw the side view projections to begin with? Because the true length of the line IJ will be observed on the profile plane which is located on the left hand side over here. So once we have opened this left side profile plane using these 2 hinges in this orientation, we will be obtaining the right hand side view projections of this line onto the left hand side. So please check point I, it is located 40 mm above the horizontal plane and it is lying on the vertical plane. So please check 40 mm above the horizontal plane and onto the vertical plane. So the location of point I has been obtained over here. So 40 mm above the horizontal plane and into the vertical plane we have obtained the location of the point I in the profile view. So this point name will become I double dash. So I double dash point has been obtained in the profile view or the side view projection. Similarly, when we are going to look at this line IJ from the right side, point J, it will be projected on the XY reference line at a distance of 50 millimeter from the vertical plane. So 50 millimeter from the vertical plane will be located over here. So this distance of 50 millimeter along the vertical plane, you can check, we have plotted over here. This is the distance of 50 millimeter along the vertical plane in front of the vertical plane. Now point J, it will be located onto the ground, that is onto the horizontal XY reference line, that is onto the horizontal plane, 50 mm away from the vertical plane. So 50 mm away from the vertical plane onto the XY reference line. So point J double dash has also been located. So I double dash has been located 40 mm above the horizontal plane and into the vertical plane, whereas point J double dash has been located 50 mm in front of the vertical plane and into the horizontal plane. So I double dash has been located, J double dash projection has been located. Now we can join I double dash with J double dash. So we have been able to obtain the true length projections in the right hand side view which has been obtained on the left hand side of the front view. So having obtained these right hand side view projections, now we will be proceeding with the evaluation of the front view projections and the top view projections as well. So we know that this distance between the profile plane and this particular line ij has not been defined. So we can take this distance to be an arbitrary distance. So distance of this line ij from this profile plane, it has not been defined. Once we take this projector line over here in the front view and in the top view at an arbitrary distance from the vertical plane, now we will be able to obtain the projections corresponding to I dash over here and j dash over here. So please check the projectors of I dash, j dash, I and j. All these 4 points, they will be lying across this particular vertical projector line. Why? Because the distance between the projectors of the points I and j measured parallel to the reference line xy is 0. So points I dash, j dash, I and j, all of these 4 points, they will be located alongside this vertical projector line over here. Now, having marked this point I double dash over here, so we can check it out over here. Wherever I double dash is located, onto the same height in the front view, we have been able to locate point I dash over here. So point I dash is located at the same height, that is 40 millimeter above the horizontal plane. So point I dash has been located appropriately in the front view projections over here. Similarly, we can check as we look at this particular point I from the top. So we have observed that this point I, since it is contained by the vertical plane, so the projection of the point I in the top view will be contained by the xy reference line. Because if I am going to look at this particular point I from the top view of this point I, it will be located onto the xy reference line. Because this point I, it is contained by the vertical plane. So any point which is contained by the vertical plane, it will be located onto the xy reference line. So point I dash is located 40 millimeter above the xy reference line, whereas point I, since it is contained by the vertical plane, so this point I will be located onto the xy reference line over here. Similarly, let us evaluate the location of the projections corresponding to the point J. So we know that this point J, it happens to lie at a distance of 50 millimeter in front of the vertical plane. So this distance of 50 millimeter in front of the vertical plane means that point J, it will be located in the first quadrant 50 millimeter below the xy reference line. So please check 50 millimeter below the xy reference line. I can mark the location of the point J over here. So this point J, I could have obtained from the side view as well. So please see, this is the distance of the point J from the vertical plane, which happens to be 50 millimeter. So through this transfer line, the distance of point J from the vertical plane, it can be transferred from the profile plane onto the top view plane over here. So this is the distance of point J from the vertical plane as it is seen by the observer looking at the point J from the side view. So this distance can be converted or transferred into the distance of the point J from the vertical plane into the top view. So this way, either way, I can draw 50 millimeter from here, or using this distance as 50 millimeter and using this transfer line, I can also transfer this distance of 50 millimeter onto the top view projection. So point J has been obtained onto the top view projection into the horizontal plane. Now let us evaluate the front view projections corresponding to the point J. Now since point J happens to lie onto the horizontal plane, so when we are going to look at this point J from the front view, So this point will be projected by virtue of being located in the front view. J dash will be located onto the XY reference line. So point J dash, this point J dash, it will be located onto the XY reference line. So please check, I dash has been located, J dash has been located, point I has been located, point J has been located. So the front view projections, now I can join I dash, J dash. Similarly, top view projections, I can also join I with point J. So I have used different colors in order to join front view projections. So a blue color line has been used to join I dash with J dash, and a red color line has been used to join top view projections of this line IJ, that is small I and small j, just to distinguish between front view and the top view projections over here. Otherwise it would have appeared to have one single dark line over here or the object line over here. So having joined the front view projections I dash J dash and the top view projections IJ, another information I have been able to obtain that the front view projections, they reveal the apparent length of the line onto the vertical plane, that is I dash J dash. Similarly, the top view projections obtained on the horizontal plane, they also represent the apparent length projections of the line IJ. Reason? Because this line IJ, it happened to be inclined to both the vertical plane as well as the horizontal plane, as it is clear from the 3D spatial representation which has been shown over here. So since this line IJ happens to be parallel to the profile plane, so onto the profile view, that is the right hand side view, I double dash J double dash, we have been able to obtain the true length projections of this particular line. So this way we have been able to evaluate the true length projections of the line in the right hand side view, the apparent length projections of this line which have been obtained in the front view, and the apparent length projections of this line which have been obtained in the top view projections over here. So the orthographic projections of the line which happens to be parallel to the profile plane and inclined to both the reference planes, that is horizontal plane and the vertical plane, have been obtained over here. So this is all for today. I hope that through this discussion you would have understood about the procedure, how do we proceed in order to evaluate the front view, top view and the right hand side view orthographic projections of a line which happens to be parallel to the profile plane and inclined to the two reference planes, that is vertical plane and the horizontal plane. So we'll be continuing with further discussion regarding few more illustrative examples related to the projections of the lines in the coming lectures. So thank you very much. Thanks a lot.